Okay, last question. This is videoM. And this is another hot-cold question. It's a lot easier than video L, where we had some nasty algebra to do. This is essentially the same type of hot-cold question, but the algebra is going to be a lot easier this time. So we have substances A and B, and we're going to put them together, and they're going to equilibrate. So we can see up here that the final temperature is going to be the same for each because they're being allowed to reach the same temperature. B is going to start out at a warmer temperature than A, and so they're going to meet somewhere in the middle. So if we look at this, we can go ahead and determine delta T for A and delta T for B. And let's see, what are those? Delta T for A, if you do the calculation, is 26.2. And delta T for B, its final minus initial, is negative 6.0 degrees. I want to point out something here. Tro has a mistake here in his key. My key is correct. His has the wrong number of significant figures. Okay, so as always, we're going to have Q equals Q. The thing that starts out warmer that's going to lose heat is going to be the negative thing. The thing that gains heat is going to be the positive thing. So in this case, B is warmer and A is cooler, so they're going to meet somewhere in between. Now, it's interesting, we can look up here at these temperatures and we can see that B is changing a lot less than A. And I think that's going to mean that our heat capacity for A is going to be smaller than B, but we'll see when we get to the end. Okay, so let's go ahead and plug in. We have negative 25.2 grams times 1.17 joules per gram per degree times negative 6 degrees. Notice also that one of your delta T's should be positive and one should be negative because one's getting warm and one's getting cold or cooling down. Okay, then over here we have 6.15 grams times Ca times 26.2 degrees. Okay, so then all we have to do is solve for Ca. And if we do the math, we end up with Ca equals 176.9 joules. And here we just have two significant figures on the top. I'm going to put a little line there to indicate that. And then on the bottom we have 161.1 grams times degrees Celsius, and that has 3 sig figs. So our answer is going to have 2. It's going to be limited by this, and it comes out to 1.1 joules per gram per degree, which is the unit we want for heat capacity. Notice that it is a little bit less than the heat capacity for substance B.